Oh, what's up, everyone? So this will be your test review for triangle congruence and Pythagorean theorem. All right, so this is your exact test. Whether you want to copy them all down and work them all out, it's up to you. Don't care. I'm going to work out most of the evens, I think, for you, unless I get lazy. All right, number 2. Determine if the two triangles are congruent. If they are, state how you know. Well, they are touching here at a side. So don't forget to mark that down. So that's a side. So this here means side. This here is a side. And then this little thing is an angle. Side, angle, side. So this is a side, that's an angle, this is a side. So SAS, side, angle, side. Number 4. Determine if the two triangles are congruent. If so, state how they are. Well, this is the bow tie. So they're touching right here. And don't forget that when you have a bow tie, you have a free angle. Right? So this is an angle, this is an angle, and this is a side. Now the side is not in the middle, so it's not angle, side, angle. This is angle, angle, side. Let's check the bottom just to make sure. Angle, angle, and side. The side's over here by itself, and the two angles are not in between, not in between. So they're both angle, angle, side. Number 6. The triangles are touching right here. That is a side. Someone make a little marker here. Alright, so right here, actually should be 3. Why should I have 3? Because this has 1, this has 2, so this has 3. This is a side, this is a side, and this is a side. And the other triangle, that's a side, and this is a side. So side, side, side in both triangles. Number 8. Determine if the triangles are congruent. If they are, state how so, or how you know. They are being touched right here, right? That is a free side. I put 2 because there's already 1 there. So let's see what we have. We have an angle, and then we have a side, and we have a side. It's either going to be that or that, all right? So let's check out what we have. Side, angle, side. Side, angle, side. So if you only look at one triangle, is the angle in between two sides? Yes. So we have SAS. Right? Don't forget that there is no as in geometry. This is where it gets a little bit different like the other worksheet. So they are telling you these two triangles, make them be AAS. Make them be angle, angle, side. And the side here is all by itself. It is not in between the two A's, all right? So in this left triangle, I have an angle and an angle, right? So I have an angle and an angle. I need a side. If you put the side here, then you have ASA. You don't have ASA up there. So that is wrong. So put the side here. Angle, angle, side. That's okay. That is correct. So WU, or UW, whatever. UW, UW, WU, UW, same thing. That's okay. Now, what happens if you don't want it there? Could you put it on this side? Is it still angle, angle, side? Yes. So then VU works as well. All right? So both of those work. And it's a side, so you can already check right here. Here is UW and here is UV. So the answer must be letter D. Number 12. You want angle, side, angle. You want angle, angle, side. So the side has to be by itself. Don't put it in between the two angles. So let me see. We have an angle. And we have a side. I have an angle. I have a side. We are missing what? An angle. If you choose angle J and you put it right here, then you have ASA. This is not ASA. It is AAS. So then you can't choose that one. That is wrong. You have to choose angle L. Now that works. Now it's angle, angle S. So angle L is correct. And where's my angle L? It's right here. Then you put it over here an angle R, AAS. That is correct. So it's letter C. Wow, another one. Angle, angle, side. Angle, angle, side. Here is my angle. Here is my side. So what angle are you going to choose? I don't know. Let's check it out. If you choose the angle here, G, do you have angle, angle, side? Yes, you do. All right. So G works. So make sure you have a G somewhere. There's angle G. Well, that's the only one that has angle G, so that's a 0. That's the answer right away. You're done. But let's check. If you do it here on F, is that angle, angle, side? Yes. So then angle F also works. That's why there's F and G. And if you do it over here, it's going to do the same thing. Angle and a side. If you put it here, it's still angle, angle, side. So K works. And if you put it over here on this one, angle L, it's still angle, angle, side. So L works. That's why it has all the 4 angles here in letter D. You want the triangles to be side, side, side. 0. All right, what was it? Oh yeah, side, side, side. So this is a side, this is a side. So all you need is the missing side, which is here. You need XV. This is your missing side here, XV. Or VX, whatever. So XV, right there. And right there. Now, think about it with a little bit of common sense here, like logically. Can you choose any other side? No, because they're already taken. This is the only one you can have, which means over here you can only have one side. So there's no way it can be 4 sides over here. It can only be these 2 here. That's some Pythagorean Theorem. Do you have the C? No, you don't have the C. And when you don't know the C, you add. So 9 squared plus 12 squared. Take the square root. Remember that. If you don't know the C, you add. Turn on the calculator so I can just get it out of the way. 9 squared plus 12 squared. Square root is 15. Here we go. Do I know the C? No. So then you add. 5 squared plus 12 squared. Square root of 5 squared plus 12 squared. 13. In this one, do you know the C? Yes. So then you would subtract. 17 squared minus 15 squared, right? Do I know the C? No. So then you add. 7.4 squared plus 14.6 squared, and then you take the square root. 7.4. Come on, calculator, get over here. 0. The square root of 7.4 squared plus 14.6 squared. 16.3, which is right there, rounded. Do you know the C? No. When you don't know the C, you add. If you know the C, you subtract. So I don't know it, so I'm going to add. 7.7 squared plus 13.6 squared. Take the square root. Screw a 7.7 squared plus 13.6 squared. 15.6. So this is 10, leave it alone. This is x. Now the square root of 197, the square root of 197. I put this in the calculator, and it's going to give me 14.03. Okay, so I'm going to erase this. It's 14.03. All right, now the same work. Do I know the C? Yes, it's 14.03. When you know the C, you subtract. Bigger number first. 14.03 squared minus 10 squared. Take the square root. 14.03 squared minus 10 squared gives me 9.84. If you notice, there is no 9.84. So then you need to find 9.84. So letter A. You put letter A in the calculator. The square root of 3 is 1.7. This is 1.7. I'm looking for 9.8, so that's obviously wrong. I'll go down here to letter C. 7 square root of 6. That's 17.614. No. Letter B. 3 square root of 33. 17.2. That's wrong. So let's check this one just to make sure. Square root of 97. 9.8. Because this is 9.8. Okay? Number 28. State where the triangles are acute, obtuse, or right. So remember the biggest number. Which one's the biggest number? Right here. This is the biggest number. This has to be C. Smallest number is A. Middle number is B. A squared plus B squared. Give some room and then do C squared. A squared is 3. So 3 squared. Plus B squared is 15 squared. And then C is 17 squared. So 3 squared is 9 plus 15 squared. That's 225. Let me add these together. 9 plus 225 gives us 289. No, I'm sorry, that's a 0. 9 plus 225 is 234. 17 squared is 289. Are they equal? No. Is the left one bigger? No. The right one is bigger. So when the right number on the right side is bigger, that means you have obtuse. When the right side is bigger, that's an obtuse triangle. Number 30. Biggest number here is 13, so that's C. Smallest number is A. Middle number is B. A squared plus B squared and then C squared. A squared is 5, so 5 squared plus B squared. B is 12. 12 squared and then C squared is 13 squared. 5 squared is 25 plus 12 squared is 144. 144 plus 25 is 169. 13 squared is 169. These numbers are what? Equal. And when they're equal, you have a right triangle. The last one here. Biggest number is C. Smallest number is A. Middle number is B. Same exact thing. A squared plus B squared is equal to C squared. A is 12, so 12 squared plus B is 16 squared is equal to C, which is 24 squared. 12 squared is 144. 16 squared, 256. If you add 256 plus 144, we're going to get 400. Now compare it to 24 squared. 24 squared is 576. So we compare the two numbers, 400 and 576. They are not equal. If they're equal, it's a right triangle. If the left side is bigger, then you have an acute triangle. But if the right side is bigger, like we have here, this is a less than sign. A less than sign, yeah. The 576 is greater. The right number is greater. That means we have an acute triangle. I'm sorry, obtuse triangle. Hello, 0. When the right number is bigger, we have an obtuse triangle. When the left number is bigger, it's acute. When they're equal, it's right.